Conversion of galvanometer into voltmeter. What is a voltmeter? A voltmeter is an instrument which is used to measure the potential difference between any 2 points of the circuit. And this voltmeter, it is always connected in parallel with the circuit. Okay, suppose this is my external resistance. Okay, let's say this is R. Now, let's say a current I, it is passing through this R in this way. So if you use a voltmeter, connect the two ends of the resistance to the voltmeter, then you will know how much is the potential difference between the 2 point A and B of this resistance. Alright. So when we measure the potential difference, we actually don't want, a current, to pass through the galvanometer. Okay, we try to minimize the amount of current which is passing through the voltmeter so that when you measure the potential difference across the terminals of any components, then you'll get the exact value. So for that, what we will do here is we will take a galvanometer. This is my galvanometer, and I connect a very large resistance, capital R, in series with this G. So please note down here that this R is very, very large compared to G, because G is, the resistance of the galvanometer, and this resistance is very, very small, in which, when a small amount of current is passing through it, then the galvanometer will always show a full scale deflection. Okay, so please don't get confused. This capital R here is just my example, but the actual R that I'm taking or I'm connecting with the galvanometer, it is here. So this R, it is a very high resistance, and I connect it in series with the galvanometer. So by doing this, then you'll get an instrument which we call a voltmeter. Okay, so what is a voltmeter? So a voltmeter is a galvanometer in which a high resistance is connected in series with the galvanometer. Okay, now let's say this is a current I. Okay, let's say, sorry, I made a mistake. Suppose I want to measure the potential difference, let's say of this external circuit, right? I want to measure the potential difference, right, across the two ends of this component. Let's say this is to differentiate from this R. Let's say this is R. I'll name this as RA. Okay, just to differentiate. Okay, this capital R is actually the resistance of the voltmeter, and this RA, it is the resistance or the external resistance in which the current, right, it is passing through it. So when a current I, it is passing through the external resistance R, what will happen? I want to measure the potential difference across the 2 point of this external resistance RA. So if you measure the potential difference of this external resistance, then I need to, I need a voltmeter. When I say voltmeter, I mean this, which consists of resistance and galvanometer. So I need this and connect it in parallel with this external resistance RA. So when you connect in this way, then you will get the potential difference between the 2 points of the external resistance RA using this voltmeter. Okay, but here, because this R, it is, as I have said, it is a very large resistance. So therefore, right, this R, right, if this current which is coming from the source is very large, if the current coming from the source is very large, then this current at this point, right, it will be divided into two parts. So because we are using a very large resistance, capital R here, so only small current can pass through this capital R. So most of the current, right, will be going through the required external circuit. So by doing like this, okay, we can now use this galvanometer as a voltmeter, because a voltmeter, as I have mentioned before, it should be an instrument in which the current passing through that, it should be very less. So the amount of current passing through this voltmeter, it will be just Ig. So this Ig, right, again it will be this, right, it will be passing through R, at the same time it is passing through G. So this Ig here, it means it is the current which is required to give a full scale deflection in the galvanometer. Okay, so by connecting like this, we get what? We get a voltmeter. Okay, so now coming to the expressions of the galvanometer current, which give a full scale deflection in the galvanometer, then you will get like this. This Ig, which is the current passing through the galvanometer, so we know this current, it is written as potential difference across the end, across these two ends. Let's say this is a point A, this is a point B. So potential difference between A and B upon resistance of this length AB, upon resistance of AB. Now this Ig is equals to, now what is the potential difference between this point A and point B? So when you measure the potential difference of this external resistance Ra, let's say that potential difference, right, it reads V. So this potential difference is V, and the resistance of this length AB, it is R plus G, because they are connected in series. So, okay, I can also say that this Ig is equals to, instead of V, I will write I capital R, okay, upon R plus G. What is this R? This R here, it is not this R, but it should be the resistance of the external circuit, that is Ra. So using this equation, let me name this as equation 1, then you can find out the current in the galvanometer, which give a full scale in the galvanometer. Okay. So similarly, if you want to find out this capital R, then from here I can say, right, if you take this R plus G and cross multiply with this Ig, you get this much. So I can say R plus G is equals to V upon Ig, or just R is equals to V upon Ig minus G. So now this is the equation for the, for the this high resistance connected in series with the galvanometer. Alright. Okay. Next, what is the total resistance of this voltmeter? The total resistance of the voltmeter, let me write as R equivalent, because these two resistances in the voltmeter are connected in series. So the total resistance is capital R plus capital G. So this is my third expression, okay, for the, this is the third equation to find out the total resistance or the equivalent resistance of the voltmeter. And please note down here that this equivalent resistance of the voltmeter, it is very, very large, okay, or it is larger than the largest resistance in the circuit, like in this instrument. Out of these two, capital R and G, we know R is larger than G. So when you find out the equivalent resistance, you will find this equivalent resistance, it will be higher than capital R. Okay. So this is how we convert a galvanometer into a voltmeter, by connecting a very large resistance in series with the galvanometer.